This video is not just another space update, because what we're witnessing right now might later be seen as a historic turning point in astronomy. In just days or weeks, NASA's HiRISE camera may drop the clearest images ever taken of an interstellar object, something that did not originate from our solar system. And before that happens, you need to know the full story, the facts, the mysteries, the silence, and why scientists across the globe are watching 3I Atlas like hawks. Let's begin. Everything you need to know about 3I Atlas before the big event happens. Most comets and asteroids are local. They were formed billions of years ago around the Sun, part of our cosmic neighborhood since the solar system's birth. But only 3 confirmed objects have ever come from beyond our solar system. 2017, Oumuamua, strange cigar or pancake shape, odd acceleration with no visible explanation, no comet tail despite passing near the Sun. 2019, 2I Borisov, first confirmed interstellar comet, unusual chemical composition unlike anything in our solar system. Now, 3I Atlas, bigger, faster, and stranger than both. 3I Atlas is officially the 3rd confirmed interstellar visitor. It is not part of Earth's past. It was not formed around our Sun. It is not native to our cosmic neighborhood. We are observing something that belonged to another star system, possibly another sun, or maybe a lost world we'll never know. The craziest part? It somehow found its way right into ours. Think about that for a moment. This object has traveled through the void of interstellar space for potentially millions of years. It survived radiation, cosmic dust, and the absolute cold of deep space. And it arrived here, now, at a time when humanity finally has the technology to observe it. Here's why scientists are focusing more on 3I Atlas than Oumuamua or Borisov. It breaks too many rules of physics and comet behavior. Let's break the anomalies down. Non-gravitational acceleration. Its motion doesn't match gravitational predictions. Something else is pushing it. When astronomers first plotted its trajectory, they expected it to follow a clean gravitational path. The sun's pull, planetary influences, standard orbital mechanics. But 3I Atlas kept deviating. Slightly at first, then more noticeably. Normal comets can show non-gravitational acceleration from outgassing, ice turning to gas, creating natural thrust. But the level of acceleration observed in 3I Atlas doesn't match the amount of outgassing detected. Something else is affecting its motion, and we don't know what. Jet behavior that makes no sense. Normal comets work like this. Sunlight heats ice becomes gas. Outgassing creates jets that push away from the sun. It's predictable. It's physics. But 3I Atlas, its jets have been observed pointing in multiple directions, including toward the sun. This suggests either internal heat sources, different surface layers with varying compositions, or something actively controlling its jets. None of these explanations fit comfortably into our understanding of natural objects. Possible layered structure. Some researchers speculate a layered internal system, almost like outer protection around a core. That's unusual. We don't see this in typical comets. Most comets are like dirty snowballs, relatively uniform composition throughout. But spectroscopic analysis of 3I Atlas suggests distinct layers with different chemical signatures. It's like the object was constructed rather than formed naturally through accretion. Changing rotation speed. Trajectory revisions show its spin rate has changed in recent months. Natural objects rarely change rotation that late in the journey, unless something internal is affecting it. When objects travel through space, their rotation typically remains constant unless they interact with something. But 3I Atlas is changing its spin in the middle of empty space. What could cause that? Internal shifts? Controlled adjustments? We don't have answers yet. Now here's where it becomes more mysterious than scientific. NASA and ESA both have active trackers analyzing 3I Atlas. Observations have already been recorded. HiRISE internal logs show multiple image batches processed, yet no official press release, no raw previews, no statements, absolute silence. Why? China's Tianwen-1 Mars orbiter already released a rare image of 3I Atlas, showing a clear nucleus and a coma stretching thousands of kilometers. So the question becomes, why is China allowed to release an image while NASA, with far better resolution, remains silent? Are they calibrating? Are they waiting for peer review? Or did they find something they didn't expect? Consider the timeline. HiRISE has imaged thousands of objects, asteroids, Mars surface features, Phobos, Deimos. Results are typically published within weeks. But with 3I Atlas, weeks have turned into months. The imaging window is closing, and still, silence. This isn't standard protocol. This is deliberate delay. HiRISE, the high-resolution camera aboard the Mars Reconnaissance Orbiter, is capable of seeing objects just a few meters wide from orbit. It has already aligned with 3i Atlas multiple times. The imaging window is almost at its peak, right now. Internal NASA data shows a NAGLI data, DTM elevation models, EDR and RDR processed frames. This means the images exist. They are sitting inside NASA's servers right now. The only question is, why haven't we seen them yet? HiRISE operates in visible and near-infrared wavelengths. It can detect surface features, composition variations, and thermal signatures. If there's anything unusual about 3i Atlas, artificial geometry, uniform surfaces, heat emissions, structural anomalies, HiRISE will see it. And the fact that these images are being held suggests they might have already seen something worth analyzing very carefully before public release. Based on the data so far, here's what scientists are watching for in those HiRISE images: layered internal composition. If spectroscopy is correct, the images should show distinct surface boundaries between different materials. Heat or energy signatures. Infrared data could reveal whether the object is generating internal heat beyond what solar radiation would produce. Controlled or unusual rotation patterns. Time-lapse imaging could confirm whether the rotation changes are natural or controlled. No tail even close to the sun. Most comets develop massive tails near perihelion. If 3i Atlas doesn't, it suggests something fundamentally different about its composition. Strange radio interactions. Earlier observations detected unusual radio emissions during closest approach to Mars. HiRISE might correlate visual features with those emissions. Non-gravitational motion still unexplained. High-resolution images might reveal venting patterns or surface features that explain the acceleration, or confirm there's no visible explanation. If any of these are confirmed by HiRISE, we may be looking at either a new natural category of interstellar object or a technological object of unknown origin. Either way, we learned something new about the universe. Let's put this in perspective. Oumuamua in 2017 shocked the scientific community. Its elongated shape, strange acceleration, and tumbling motion sparked debates that continue today. Harvard astrophysicist Avi Loeb suggested it could be artificial, a light sail from another civilization. The mainstream rejected this, but couldn't definitively explain all its properties. Then came 2i Borisov in 2019. More comet-like, but with chemical signatures never seen in solar system objects. It proved interstellar visitors could be diverse and unexpected. Now 3i Atlas combines the strangeness of Oumuamua with better observational opportunities. We're tracking it earlier, with better instruments, from multiple angles. This is our best chance yet to truly understand what interstellar objects are and what they might mean. Right now, the global space community is watching. Data analysts are checking the HiRISE portal every single day. Amateur astronomers are tracking it nightly. Astronomers are coordinating observations across multiple wavelengths, because at any moment, NASA could release the most detailed image of an interstellar object in human history, and depending on what it shows, our understanding of space could change forever. Think about it. In the history of human astronomy, we've only definitively observed 3 objects from beyond our solar system. 3. And we're watching the third one right now, in real time, with the best imaging technology we've ever had. This isn't just interesting. This is historic. The next few weeks are critical. HiRISE's optimal viewing angle won't last forever. As 3i Atlas continues its trajectory away from the inner solar system, our window to capture detailed images closes. Once it passes beyond a certain distance, even our best telescopes will only see a faint dot. We'd need to understand why interstellar space produces objects so different from our own solar system. If it's artificial, we will face the biggest question humanity has ever asked. Are we alone? The implications would be staggering, not just scientifically, but philosophically, culturally, historically. We would have proof that intelligence exists beyond Earth, that technology can survive interstellar journeys, that someone, somewhere, built something that made it here. Both possibilities are profound. Both change everything. So we wait. We watch the HiRISE data portal. We track amateur observations. We read every preprint paper. We analyze every spectroscopic dataset. We'll see its surface features, its structure, its composition, its mysteries, and we'll know. Stay tuned, because when those HiRISE images drop, we may witness science fiction becoming science fact.